Good evening, everyone. My name is Claire with my colleague Emma, and our research is about the speech assistive technology for individuals with speech impairments. And the keywords we have the MFCC, male frequency, coefficients, SL, specific language impairments, ZCR, zero crossing rate. And here we have the exploratory data analysis. And this, okay, according to our project, it's all about, we got the data sets for the sick people, like these people who are stammering, and the data set for health people who can speak very well. So we compare them and we get the fine, let me say that fine voice, nice voice, in order to cater for those that are impaired. So this graph is showing, it compares the size of the health and the sick, the SL that represents the sick people that are stammering. And the x-axis, let me say the x-axis represents two classes, that is health and the sick. And the y-axis is representing the data sets, the data sets. So it shows that the health data set is smaller than the data set for the sick people. So, and for the continuation, it is showing that even the pie chart is showing the same thing. And it shows the portion of the data from each class in relation to the total data set. So the health data set takes up the smaller portion, and the SL dataset takes up the larger portion. And the pie chart provides a clear picture of how the datasets are distributed. Yeah. And for here we have the waveform of the audio files. So after getting our datasets, first of all, they were zip datasets. So we extracted and we got the audio files from the datasets. So here we have the waveform of the audio datasets and showing the healthy and the SL, which we are going to see here. So let's first see the health speech sample. So these are the samples. First of all, health dataset, their voices from the health people. So you can hear, okay, those voices are accurate. So the waveform this one represents the health speech file. And of course, as shown, x-axis there is time, and the y-axis we have the amplitude of the audio signal. And here we have the continuation for another audio file for the sick people. And it might show the differences in the speech characteristics, like in pauses or intensity variation, since it is not a clear audio. It contains voices for people who who are speech impaired. And another part we have the plot spectrum, and we are starting with the for the health speech spectrogram. And here we have the health speech spectrogram, and it represents the frequency content of the speech sample for the health speech class. And it displays the consistent frequency bands with clear energy distribution. And here we have for the sick people, SLI, like, yeah, for the impaired people, which represents the, yeah, it may show the irregular patterns, low energy or disruptions in the frequency bands, indicating the speech impairments. Thank you.
Hello everyone, this is Emmanuel Asikwai, and we're going to continue from my short statement. So, as she previously said, we're working on a project which is enhancing speech among the people who have speech impairments, who have challenges with their speech, those people who stammer and can't communicate effectively. So this is basically the design of our project to assist those people be able to help them. So first of all, we worked with the exploratory data analytics. And these are the results of our EDA code. We could not extract every part of the results. We only extracted out the features because the results, if we were to extract everything in the results, that would mean like extracting out the data files, the data set itself, and the lines of code that run behind. So we only extracted out the features in the EDA code that were displayed when we worked with the data set. So I'll begin with this. So this was the distribution of the zero crossing rate. So this is a feature that is used to describe the data sample itself. So you're going to realize that in this data sample, we have the SLI, or the specific language impairment people. These are the sick patients. These are the patients. This is a data set for patients. And then this is a data set for healthy people. So in the data set for healthy people, we see it has a high zero crossing rate. In the data set for the sick people, it has a high zero crossing rate. Or the data set for the healthy people, it has a low zero crossing rate. So the zero crossing rate is dependent on the signals or the frequencies that are portrayed in the data. So for the healthy people, the data is almost clear and has very few signals. So that explains as to why healthy sample or the healthy patients, the healthy patients data set has a low zero crossing rate, while the sick patients data set has a high zero crossing rate. So that's all about the zero crossing rate. It's just how it exceeds the 0 point, the crossing rate of the 0 point in the count. So then the spectrocentrate. So the spectrocentrate is almost similar to the zero crossing rate, only that for us, it's about the centering of the data itself. So when you look at the patients who are sick, the SLI, and the healthy patients, the healthy kids, these are children, the healthy children and the sick children. So you realize that the sick children have a very high spectrocentrate as compared to the healthy children. The healthy children have this low spectrocentrate, and the healthy children have this, the sick children have this high spectrocentrate. So that is it about the data set in the spectrocentrate. Next is the MFCC. This is male frequency substrate. Okay, that is male. It's MFCC. So in the MFCC, this is about the frequencies that represent human perceptions. So you're going to realize that the SLI, the sick children, have a very high MFCC, as compared to the healthy children. This is because the sick children have higher frequencies or higher audio clips. They have tendencies of variability in the audio clips. Remember that the waves that are recorded from the audio clips for the sick children have a high variability. They vary in sound signals. Find when there is a very high frequency in one side as compared to frequency in this other side. So since there is a high variability, this causes a tendency for the data set to have a high MFCC as compared to the healthy children who have this low MFCC. So next is the healthy speech samples. So you're going to realize that this is sample one. We had multiple samples. So you're going to realize that sample one is a bit concentrated, the one for the healthy children. You see this sample is concentrated, even this sample is concentrated. As regards to the sample for sick children, you're going to look at the sample of sick children having a weird concentration in the middle, and it would have different overlaps where it has highs and drops. So this one is average a little bit. If you look at this sample, also look at this sample, the result has a concentration in the middle. So compared to that sample of the sick children. So this was a waveform for the healthy children. These were the varying samples. And when you look at the samples, they're almost similar. There is almost no distinction, though there is a distinction, but it's almost negligible. There are more similarities in the samples as compared to the differences. Then we shall proceed to the sick sample, the sick children. So the sick children, now you realize that there are many drops. So there is a high concentration, then it drops rapidly. There is a high concentration, then again it drops rapidly, which we did realize in the sample of healthy children. This is because of the various signals that vary in the speech or the audio sounds or audio clips that we received in the data set. So there are various drops in the data set. That's why we had drops and rises in the sample that we form for sick children. Then, so this is sample two. The other one was sample one, and sample two. You also realize that sample two is the same. As regards, we've made various samples and they were exactly the same. The one for sick children had these serious drops, and the one for healthy children had average drops, so it was entirely average. Then we go to the spectrogram. So the spectrogram is basically a feature that specifies or concentrates on the frequencies or the intensities of the frequencies in the audio clips. So you're going to look at the spectrogram for healthy children, which has more or less of like bright colors. It has less bright colors as compared to the spectrogram for sick children. So because of the frequencies in the spectrogram, because the one we used is one that uses line, it's a linear spectrogram. There are different kinds of spectrogram, what types of spectrograms you can use. One is the null spectrogram, which bases on human perception. The other is the logarithmic spectrogram, which uses logarithms. So this one you're using was a linear spectrogram. So you can realize that this one is less bright as compared to the one of the sick children, because the one of healthy children has lower frequencies in the audio voices or the audio waves, because these audio waves are uniform. They are more concentrated as compared to the one of sick patients. So you realize now the one for sick patients is a bit bright, as you can see these serious spots in the spectrogram as compared to the previous one, which was almost uniform. So this explains as to why the spectrogram is that. So this is basically what we presented about some of the features we had, and it has been Asim Emmanuel. Thank you for listening, guys.